Oh, definitely come in person. Oh my gosh, no. If you have the option to go to a conference, go in person. That's the whole point of conferences.
All right, I think we're right at time. So hello everyone, my name is Mike Shah. Welcome to the talk, The Factory Pattern. It is labeled under Back to the Basics in a sense, but it's part of the software design track, and I'll talk a little bit about that in a moment. All right, so here's the abstract that hopefully got you interested in this pattern and drew you in here. That's what we're going to be talking about today. And just as a reminder, all the code for my presentations is going to be up on GitHub. And I know since the slides might be hard to see for some folks attending today, I'm going to put the slides up there right away as well. So who am I? In brief, Mike Shah. Primarily, I teach at Northeastern University. I do some consulting, and you can read about me on my webpage as you like. And today's going to be an interactive session, so feel free to shout out answers. I'm going to try to get some participation. Folks are online as well. I'll look forward to your participation, and for future folks watching on YouTube, comment and like below. Or dislike if you dare. So this was a question I was just actually asking folks at the conference earlier. And I was just sort of curious, how did folks get started in programming? What sort of piqued their interest? Anyone in the audience?
Video games.
Video games, okay. Anybody else?
My brother just wanted to see if I could learn some programming.
A brother wanted to see if he could learn programming, a challenge.
Brain damage to me.
Robotics, very cool. So a wide variety of domains here, okay. So, you know, just to throw me out there, it was video games for me. Of course, that was my interest back in the day. Spent a lot of time playing them, and then I was interested in, well, how do you make them? How do you break them? And, you know, how do you do all this cool stuff? So that was largely my motivation in getting started to program. And for this talk, though, you know, I don't really care if you like games. That's totally fine. Or if you don't know anything about them. But I do think they are going to be an interesting use case for us to look at in terms of this pattern and thinking about a real-time system. That is something that has to process fast, something that's very dynamic in nature, something that's changing. I think video games are a nice domain we can walk through. So, and just to sort of illustrate this point, on the right here, I've got a screenshot of Command and Conquer, which is a video game in the 90s. And again, we don't have to understand what's going on here, but there is a lot going on. There's vehicles moving around, there's, you know, objects being created, destroyed, there's artificial intelligence. So there's a lot of stuff going on in games that makes them, you know, relatively interesting when it comes to the challenge for software architecture. So for today's talk, I want us to think about software design and specifically for this real-time application. The pattern that we're going to be talking about is applicable in many domains, but I'm going to think about it in sort of a video game context. So my expectation, and again, why this talk exists, I mentioned it's part of this sort of back to basics track, but also in the software design track. Klaus and I have put together this sort of software design track to spread some knowledge about software architecture. Klaus getting a lot of credit for the work this year, and we wanted to have some sort of tutorial-like or back to the basics material for this, so covering different patterns. So something for folks to think about in the future or look out for these sort of design pattern talks. So this probably isn't an expert level talk for folks who have read some of the famous books like The Gang of Four, but I'd encourage your wisdom in the audience if you do see things that jump out or that you'd like to share. And otherwise, it might be interesting to hear your insights on the different trade-offs with this pattern. So the design pattern of today is, well, most of you have seen the title, but I'm not going to spoil it just yet. So let's think about what our goal is in our domain here, in our video game. And you know, largely, I'm just going to say that this is a user-driven application. A player's controlling the game, they're making decisions, they're creating objects, destroying them, and so on. So my question to the audience is, if I have a user-driven application, and part of that game is that the user gets to create objects. You can see in this animation playing on the right there, clicking on the user interface and then creating some building here. How well do you think as a developer I can predict what a user is going to do at compile time? Meaning, how many objects are they going to create? What are they going to do? What types of objects? What do folks think or are thinking about? Not very. I see head shakes. Nope. Yeah, especially in a game that's very dynamic, right? You're going to get lots of different people who play games in different ways or bend the rules, or games again are very dynamic. But with this in mind, I want to walk you through my sort of thought process here. And we could try this, right? This seems like a reasonable thing to try, just to take a guess. And maybe some of us like this. Sometimes in games, we actually do like this, to sort of pre-allocate or figure out ahead of time how many objects we're going to have. So in this slide, what I'm showing here, I have object type 1, 2, and 3. And I've named them units 1, 2, and 3, and there's 100 units each, okay? And 100 feels like a good number. Maybe I have some intuition about what happens in the game. I can think that's enough. Maybe we could restrict somebody who's playing the game from having more than 100. Maybe reallocate. That could be an option if they go over that limit. Any thoughts on folks? What do they think about this?
It's good to have a maximum so that they don't overflow your memory.
Yeah, it is good to have a maximum here. So we do have a cap or some notion of that. So that's probably some constraint we're going to want to enforce somewhere. I like that. But some thoughts for video games, just in our domain, these objects could be very large, depending on what data they're holding or how much information. So if we're allocating hundreds of them, maybe we're okay in this system, but maybe we're going to have too much stuff on our stack here, in our stack memory. Maybe we're doing this in the main function, maybe another function elsewhere. So we do have to be a little bit careful with some of these numbers. And maybe that is how we sort of figure out our upper bound, but maybe we want to use a different piece of our memory, right, and dynamically allocate so that this will be located on the heap. So we can, again, start off with 100 units, and I can try to resize this if the player goes over the limit. What do folks think about this? So let's say someone breaks, they're playing the game, they're really good, and they create more than 100 units. They're up towards 1,000 or something. What might be the problem in a game? A couple of things.
One, you have to wait until that resize.
So the comment is we have to wait and resize because we're growing our collection. Yeah.
Also, you can't use the objects that have already been instantiated until that resize is done, because they're making slots.
Yeah, so the second thing, the comment is, as we're doing this copy, right, because they're in flux and information's being copied, we're halted or blocked on that operation, in a sense. So that's kind of a problem, whether we're increasing or decreasing. And of course, this is some sort of O of n operation. Very likely it's an O of n operation. Maybe there's some trick we can do, but this is expensive, whether we're increasing or decreasing our size. So let's kind of get rid of that so I don't have to manage the resizing. And we have data structures to do this, right? We have std vector, perhaps other collections that might be appropriate. So let's just pack everything into a vector. That gets a little bit around this problem. We're still resizing and doing things, but it's a more flexible container. Now, what if halfway through, again, I'm a game developer, I'm building this game, and then I decide, well, object type 3, we just don't like that. It doesn't make the game fun. We don't have time to ship that extra feature with this type of object. Well, what happens is I have to delete it everywhere. So I've just got these types that are also hanging around here. So I also don't like that part of this design as well. And okay, so I've gotten rid of object type 3. I've just got my two different object types. And they've each got their vectors where I'm going to collect the units so everything's sort of together. But how am I, again, going to create these objects? Now I'm keeping track of different vectors where I'm pushing objects. I still have that obligation. And maybe I want to create this object type 1 here with no constructor, the default constructor, and object 1 here with a different constructor with 2 parameters. Okay, so now I'm making some decisions, and again, maybe that's okay, and I'm trying to figure this out, but it's getting a little bit complicated here in this code. And we can imagine if I'm trying to do this ahead of time before the game's built, to sort of set the user up for the game playing experience. So, am I able to guess at compile time which to use? Maybe I have some control over that, but again, this is a user doing something very dynamically. So instead, what I'm going to do is try to fix this by pushing some of this work into a function. Because this is something that I'm going to repeat, creating multiple objects and then pushing them into some container data structure. So I've got this function here. It's called makeObject1 and push to vector. I'm very explicit about my names here for the purpose of this talk, but that takes in our vector. We're passing in by reference. So we were careful to do that for performance. And it takes some parameters, maybe the x and the y position of something in the game where it's located. Okay, and then we can handle that. Okay, so that's a little bit better. And maybe I can generalize this a little bit. And certainly I can have parameters. Maybe there's different parameters, but I also have to kind of update these and keep track of them. And again, I have to be careful with how I'm passing my collections in. If I pass this in without the reference, then I'm passing by copy, and that's potentially very expensive. But we are getting closer to something interesting here, where I'm trying to abstract out this idea of creating my objects here. So I've got a function here that's called makeObject, and it takes a parameter int for the object type. Okay, so maybe I've got different airplanes, cars, vehicles, and those have a different number associated with them. Okay, so I can kind of parameterize how these functions are being created. And then maybe I've got some params here. I don't know what they are, but int param1, int param2, and maybe some of them are used for some object types, maybe not for the others. And the audience is squinting a little bit at this and sort of nodding their head and saying, what's going on? Or they can't see the slides. But, we've also made some other sort of weird decisions here where I have, as I'm just thinking about this problem of moving our vector out to some sort of global structure where we can keep track of things. So, I still don't like this. It works. You'll be able to run my code. But in a way, it's sort of like the ostrich saying it works, and then they kind of dip their head into the sand and say, but I'm not going to look at it. It compiled, I'm leaving. So, this is a practical solution that works, or I shouldn't say it's practical, but am I done here? And how do I know when I'm done? Is this a good piece of code? What's our audience think? Pardon? It's a judgment call. Okay, so that's a comment. What kind of things might I be judging on?
When you have to release, like the amount of time and effort for testing and factoring, the way it interacts with the code.
Yeah, so some of the comments when the release is, right? If the release is tomorrow, maybe I don't care. This is good enough. The second was a hint about, do I have to maintain this code? Do I have to test this code? So those would certainly be important things, and that's where we're gearing towards, of course, here. So, I can give us some sort of 3 criteria for when I think a piece of code is good. There is sort of a notion of good enough, right? This is economically driven. That was another one of the comments, right? So if the deadline hits, maybe we're good enough. But I like to sort of think about code that I write in that it's flexible, maintainable, and extensible. Not terms that I've made up. I've borrowed these. I'll show you where I've borrowed them in a moment. But if I sort of look at this code and evaluate it, does anyone have any thoughts that this is this flexible code? Is it maintainable? Is it extendable? Could I add other different object types to it? I thought, yeah.
One thing I don't like is that all of the parameters for any of the object types must be passed in, and most of them are no-ops.
Yeah, so the comment was, most of these, I always have to pass in some parameters. And in the case number 2 here, where I'm creating this new object that doesn't even use them, I'm essentially, it's a no-opt, right? We're wasting computation here.
It's not very extensive because you'll have to continue adding parameters.
Yeah, and it's not extensible. So we kind of fail that check here, right? Because if I add object type 3 and it happens to take 8 parameters, or a string, or something that isn't just an integer. So we probably want to work around that as well. Yeah, so I think it's kind of failing there. Maybe we can work around it, but any other thoughts? And I'm going to be pretty generous with this code. Let's see. So I've given, and again, you don't have to read this wall of text, but red is kind of a fail here. So we've sort of failed flexibility, failed maintainability, and extensibility. Well, I was generous. I said we can add more object types, but we do have to, do some work here. So on the flexibility, right, we can sort of extend our object types. The parameters, as was mentioned from the audience, is sort of a problem. Maybe we can have specific object param types that we're passing in, but this is sort of getting very nasty code to it's not very flexible. We have to keep track of a lot of things. Is it maintainable? Well, again, probably not, right? If I remove an object type or I change a data structure, I'm diving into this code and, was it 2 that equals object type, or, was it something else? Or, so we could have gaps here. It's probably not robust code. What if a user passes in 1,000 as the object type and it doesn't exist? They just get no object, no warning. So I'm generous. I'm going to give this a 1 out of 3. Because it's my code, I give myself 1 point. So the problem that we're trying to solve here, or at least my claim is, if I have a user-driven application, a game, something that's very dynamic, one, it's going to be very difficult to figure out how to create objects of different types, right? We've tried to do that with passing in integer values as a parameter. And again, that's hard to sort of predict. We will revisit this point by the end. And then it can also be difficult to figure out where to create the objects. Am I just doing this in a bunch of free functions? Does it happen in my main? So those are some design decisions that I have to think about and commit to and be convinced that it's extensible, flexible, and maintainable. And again, any of these problems that I'm looking at, we usually want to consider them at scale. So not just 2 different object types, but what if I have hundreds or thousands? Okay, so again, let's think about this game just looking at it here. Again, we don't really have to understand what's going on other than there's a lot of different units moving around here, different objects in the game. And we're able to create an undefined amount here. So what's the right pattern here? How do we solve this here? Okay, well, luckily, there's been some smart folks well before me who have figured out some patterns to help us. And these are called design patterns. I'm going to give a quick rundown of what that means. But design patterns are templates or flexible blueprints for developing software. They're not a one-size-fits-all, but they're a template, something that we can at least start from to implement in our game here. And on the right here, I have a few of the texts that I think are particularly good at explaining design patterns going forward, which I'll link at the end. So again, design pattern, it's a common repeatable solution for solving a problem. And ideally, design patterns make our code more flexible, maintainable, and extensible. Here's the famous Gang of 4 book design patterns, still relevant today. And there's lots of nice code examples in this text, so I would recommend that. And I also really enjoy this textbook. It is freely available, but I've purchased a copy because I think it was great by Robert Nystrom, called Game Programming Patterns. Again, doesn't matter if you care about games or not. It does a nice job in the game domain highlighting the different patterns. Okay, so what does the design patterns book give us? Well, again, these reusable templates. So specifically, it gives us 23 patterns for solving problems that tend to keep showing up in software. Okay, and then it's your job to sort of identify the right pattern that fits the problem that you're trying to solve. And today we're going to focus on creational patterns, and in fact, just one specific of these creational patterns here. Okay. And what is a creational design pattern? So there's creational, structural, and behavioral. We're worried about creating things in our game, so we're going to focus on that. So briefly, in a slide, what I could say about creational design patterns is they provide a little bit of flexibility on how we create objects. And often they shield us or protect us from having to directly instantiate an object, meaning we don't have to figure out what the type is, allocate memory, figure out what the right allocator is here, new, and then the type here. And then even we can go as far as picking the right constructor for the user. Okay, so we sort of prefer this if we have an easy way to construct our objects. Okay, so where we left off with this pattern here, make object, where we were passing in an integer for the object type and some amount of parameters. Well, this wasn't very good. We decided it didn't really meet our criteria here. So we do need to think a little bit more about our object type structure, because that's sort of interesting that we at least know we have different object types here. So just a quick one slide refresh on object-oriented programming. Something that's in our toolbox, so something that we have to decide whether it's a good tool or not for us to use, is inheritance here. Right? So the sort of canonical example here, if you have some base class that's an animal, you can derive a class or inherit from that class and create something called dog, and a dog is a type of animal. And that's pretty cool for things like code reuse, but what it's really nice for is setting up this relationship to say that a dog is a type of animal. And in C++, that means we have this polymorphism, or inheritance-based polymorphism, right, where a dog can act like it is a animal. Okay, so we were close in solving our problem. Again, maybe if the deadline's tomorrow, we are done, so we've solved it, but we want to do better here. So we want to set up some sort of object inheritance hierarchy here. Okay, so this is going to be good for two reasons. It's going to help simplify us creating different objects, and it's also going to help enforce what sort of properties those objects have. So, I have a lot of these sort of virtual void. These are purely virtual functions, meaning that we have to implement them from any class that's derived from iGameObject here. Okay, so GameObject's just a general sort of interface. And usually I prefix things with capital I to indicate that it's an interface or it's meant to be derived from. This is a base class. Note on my slide where all these examples are available. Some of them are not always efficient. But if you spot errors, I don't have any chocolate or anything to give to you, but I can figure out something. So, so we want some sort of inheritance hierarchy that maybe looks something like this. So we have our iGameObject, and then we can derive our new objects, object type 1, from this iGameObject, and, well, really as many as we have. So here's the nth game object that we have. Again, establishing this relationship, object type 1 is a iGameObject. Okay, so it's derived from this base class. All right, so what does that look like in code? I'm going to be showing code. Again, these are functional examples. And, well, if I look at the top left of the screen here, I have a class here. It says object type 1, and it's going to inherit from iGameObject. This will actually publicly inherit from it. I'll fix that in a slide for a moment. But we can see what's happening with object type 1 is it has to also implement all these other member functions. Object, play a default animation, move the object, update the object, render or draw the object, all these different behaviors that we want. Okay, so let's make this subtle change, make this public inheritance, so we get access to everything here. And another sort of subtle change, so I'm not talking about object 1 and object 2, we now have a plane and a boat. So we have two sort of concrete objects here. Okay, and they're deriving from this iGameObject class. Okay, so let's go ahead and update this function to create objects. So what I have on the left is what I started with. Again, I was just making an object, passing in integers. We didn't like these parameters. Yeah, we could have maybe made some other data structures or changed it, but we're going to get rid of that and start taking advantage of the inheritance that we've created with this hierarchy. So on the right side here, I have a new function. It's called createObjectFunction, and it still takes in some sort of object type, O here. Okay, well, what is object type? That's a little bit of a relic from our past. But if I go up here to line 38, I've actually got an enum class here where I'm trying to protect myself a little bit. So my object types here are plane and boat. So I have to pass in one of these, either object type : plane or object type : boat here. So I sort of like that. That's better than the integer. And folks can feel free to disagree if we've got trade-offs, but that seems safer to me. Okay, I know exactly how many conditions I need to handle. At least these two. I have a comment below that I should probably handle a default case as well, but I at least have these two cases. Okay, so what is this function actually doing? createObjectFactory. Well, it's returning a iGameObject pointer. Okay. So the job of this function is to figure out what type we have and then return that type in terms of a pointer here. Okay. So then each of the cases, I return a new plane and I return a new boat. Okay, and I'm choosing the explicit constructors that I want and how I want things initialized here. Okay, so again, just recapping, I have this enum class that's going to specify the different types of objects that I can pass here. I could have also done this on the left side. That's true. I could incorporate some of these changes. But again, we're going to have the right type here. Then the second major change that I have here is, in a way, I've simplified the function. Right now, it's just a switch statement on the object type. And I'm just returning the memory, so I'm allocating this on the heap, to some type of iGame object. And again, I can get away with this because a plane is an iGame object, a boat is an iGame object, etc. And what's also interesting about this code here, I've called it createObjectFactory, is we're sort of moving towards some of our solid principles. So the S, where we have a single responsibility principle. I won't claim that this is a super concrete, but at least for now in this toy example, all of my object creation is now in this one function. Okay, and I sort of like that. There's one place to do that. And one more small change here to keep up with the modern times, just to sort of demonstrate. And this is something you'll have to make a design decision about. For a game, I think it's appropriate, but I'm actually going to return a shared pointer here because I want to be a little bit careful with how I'm managing resources. But I'm going to return this shared pointer to a plane or shared pointer to a boat and do that. Right? The pointer is going to protect us, give us a little bit of protection in terms of deallocating or freeing these resources, as well as objects and games. Maybe they have something expensive associated with them, some pixel data, textures, animations, or whatever. All right, so how am I using this in my main loop? Because I've got this handy function now where I can create objects. So here's what my main loop looks like. And okay, one thing that's nicer is at line 55 I'm looking at, I just have this game object collection, which is just a collection of my shared pointers for iGame object here. Okay, so I sort of like that, just one collection to worry about. And C++ will take care of resolving, what the actual type is here. So now I can do game object collection, pushback, and then it's nested in this statement here. createObjectFactory, my enum class, object type, : plane. I do that 3 times and my boat. Okay, so now I've got this function where I'm creating things and pushing them into my data structure here. Okay, so I sort of like that layer of abstraction. That's becoming a little bit cleaner. And a side effect of this as well, just the way that I've structured this and used some inheritance is, well, in my game loop, I can now just iterate through my entire game collection. Okay, so then I can just call whatever this element is and update and render it. Okay, so that's sort of nice and clean. These are all game objects that implement these different functionalities. Now, just a brief aside on this loop here. This is for my experts in the audience. We probably want to refactor this code if we are thinking about things like performance, caching, how we're accessing these objects. But for now, that's a separate talk, and I think there's been several good ones on that. I will point you to the game programming patterns book, which talks a little bit about that, because I think this is a concern, but not the focus of this talk. Okay, what have we done here? Well, from the title of the talk here, we know that this is about the factory pattern here. And specifically, we've implemented what's called the factory method, which is a creational design pattern, right? So what is the factory method sort of defined? The factory method pattern provides a generalized way to create instances of an object and can be a great way to hide implementation details for derived classes. Okay, so let me just kind of break that down. So our ability to create instances of an object. Yes, we can do that. Right? So we have our create object factory with the different object types. And this is sort of a generalized way to do so, right? Just from this one single function. And everything's an iGame object. So I like that so far. And we can even extend this a little bit to do some more wild things. So, I don't have a different type necessarily for a plane in the air. So I've added to my enum class here, plane underscore in air. And I can add a different case that instantiates a plane that's, well, if these are X and Y coordinates, maybe, 100,000 means something as far as, how high you are in the coordinate system. So, we can kind of extend this and play around with this example a little bit. So again, I like that. Okay, so now I've added this plane and air condition, which calls the same constructor, but with different parameters for something that we might commonly want to do in our game. So about this other point, though, the second part of the factory method, it says it's a great way to hide implementation details for the derived class. So this I haven't really talked about too much in a sense that I'm introducing it now, but I did spend a few minutes to refactor this code here. And what we're looking at here is the header file, or factory.hpp, and this is what I'm actually exposing to the client or somebody who's going to use this in a game. So what they're going to see is, okay, well, I've included memory here, but I have a class, iGame object, and that's tends to be nice. I don't need to include the whole header file. I have my enum class, which, we could hide that somewhere, but for now I'm going to leave this to the client just so they can see the types that they have here. So maybe that's something that could be improved on. But then they just see that we create an object factory here. Okay, so that's kind of nice. There's no implementation details. I didn't have to provide all the code necessarily. So, I'm happy with this part of the pattern here. Okay, so no design pattern is perfect, though. And again, computer science is all about trade-offs. That's what I always tell students. And this is another sort of audience question. So what do we like about this? What are the pros? What are the cons? Are we happy with what we see here? Give folks a moment to think about it. Yeah, Jason.
I kind of have a software. Implementation question is, when Herb Sutter presented on factory pattern in C++ 11 like a million years ago, he recommended returning a unique pointer from your factory so that then the consumer can decide if they want to pay the cost of putting in a shared pointer. Notice in your examples, you're just returning shared pointers. So just curious about your thoughts.
Yeah, so the question was, Herb Stock, probably many years ago, 10 years or so ago, where shared pointer, unique pointer, and these kind of things were new. I could return std unique pointer here for my game object, and then then I have one pointer, and then it's my decision to make a copy of that object and put it in a shared pointer if I think it's something resource intensive. I think that's absolutely reasonable. In a game, for us to default to the shared state case, maybe it just depends what we're doing. In the specific game case, if we have a lot of things that are repeating, textures and some of these things, I guess we would need another level of abstraction where we're grabbing those things from a texture managing class or something and then just send those into a unique pointer for this object. So
if you do the unique to shared pointer conversion, no copy or anything has to happen.
oh, there's no copy for the conversion from unique to shared?
Yeah, but the only thing that
It's just movable?
The control block for the shared pointer has to be allocated. So you went from having one allocation of things shared to two separate allocations when you do that thing.
Right. Okay. Yeah, that's probably more efficient. Especially, if we're using this create object factory, especially if it's something, think in games terms or a very dynamic application where there's lots of particles or creating like hundreds or thousands of objects, I think that's a good default. So that's probably a better default. Yeah. Come in.
One thing that you lose in this particular implementation is the ability to provide parameters. So in the original implementation, you could customize how the objects were created.
Yeah, so we've, the comment was, previously we were able to pass in parameters, and that could be powerful in a sense of the different types that we could maybe create. That almost leads me to other creational patterns, things like the builder pattern and some of these things, which would be another talk, but that's the keyword. So yeah, we could have that, right? We did sort of this hacky thing where I have plain underscore in air and said, okay, that's another type and I'll special case it here. So that's a trade-off. Maybe that's okay, but I would say if we do it more than once and we don't, we're documenting this, we probably want to fix that, right? We can add some more power to our factories here, right? This is just a single method, so we will add some more power momentarily. Any thoughts? Does anyone want to give a check mark or a yay or nay for flexible? Okay, so some loss in flexibility since we can't pass in the parameters. Yeah.
Maintainability, if you have a small number of different type objects, it's fine. If you have hundreds of objects, this becomes unwieldy.
Okay, so the comment was for maintainability, small number of objects, probably okay to have our switch cases here. So this is where the nuance comes. If we have 1,000 objects and I have to have cases for each of them, maybe not optimal. Yeah. And extensibility, can we add new types here? I get a thumbs up for this one. Okay, so that one passes. And we got some cons. Let's see what did I commit to on the next slide as pros and cons. So I bailed myself out here. Flexible, relatively flexible. Okay, so we can sort of run with this, right? We lost our parameters. Maybe we're gonna end up creating a lot of different types. Maybe we want some other pattern combined with the factory. And what I will say is factory tends to be one that gets combined with other patterns. So maybe it's in a singleton that you find a factory, or maybe it's used in conjunction with a builder to build many different types. So I think we could improve on this. The maintainability, we have one update to the enum class and one update to the switch statement. That's not too bad. Maybe that's okay. Maybe we can do this in a more data-driven manner, which is where I'm going to move us momentarily. And the extensibility, creating new objects is pretty easy through inheritance. Right? We just inherit from a base class. We like that. Some of the cons, though, we might need several different factories for different hierarchies. So we do have to think a little bit about that and how we might abstract that. That's actually going to be another pattern that I'll mention. And I still don't like updating in two places. It's okay. It's not the worst thing in the world, but it's, we've got to judge what our code base is here. To the comment below, you should probably think more about if you want to use shared pointer or unique pointer. So I've covered myself in some way, but that is something that we do need to think about. So some other just neat ideas with this pattern, though, is we can make our application more data-driven with this pattern. I think it's a little bit easier. So what I'm showing here, I'll draw your attention to the bottom left corner. I've got this file I just call level1.txt, and I've just got a listing of the different types of objects we might want to create. A plane, a boat, a plane in the air. So that's sort of our configuration. And on the right side, again, we don't really need to read the code, but I've got my game object collection. And I'm just going to read from this file. And if the line equals plane, well, then I call the game object collection, push back, and then set up my factory to make a call to make that plane. Okay, so I sort of like that data-driven approach. I don't have to recompile. Again, if you're working on a team that's not all engineers and maybe a artist or a game designer just has to work in this configuration file to test out different things, that's usually a good decision. If we're willing to pay a little bit of cost to just read in the data here. The other sort of neat idea or thing that we can get from this pattern a little bit more easy is sort of tracking our object counts. Now this is one I could imagine doing a number of ways. I've taken what I think is maybe the easiest, where in each of our classes, like plane, you have some static that just counts the objects created. Okay, so we could have other manager classes or iterate through our collection if we want, but we're doing a little bit of information gathering here, and I think that's sort of nice, and just containing it. Okay, so looking back to our earlier question, how well do you think I, as a developer, can predict at compile time what objects to create? Well, in a game, you might exactly know, actually, depending on what's going on, right? And there's systems for sort of recycling objects and stuff, but you could let somebody play, see how many objects are created, and gather some metrics here. Okay, so this pattern could help with that. All right, but let's focus on making our pattern a little bit more extensible here. And this is a pattern, it's called the extensible factory from Alex Andreescu, who wrote about it in Modern C++ Design. And I'm basing my example based off of Martin Reddy's API Design for C++ book, which is a really great book for picking up patterns and good practices in C++, in my opinion. Okay, so our goal with this pattern is to allow us at runtime to create new types. So we figured out, that we can make our application a little bit data-driven by reading in from a text file the things we want to create. But what if a user says, hey, I want to create my own type, or we want to, add different objects? So what I'm going to do this time is I'm going to create something called my game object factory. Okay, this time I'm going to package things together into a class here. And my class has all static member functions for now. I want to keep things simple. It's essentially a singleton, so depending on how you feel about that, you might have comments. But let me draw you to the key components with this extensible factory, or why I'm going to argue it's a little bit more extensible. So there's really two key functions that have been added here. And it's our ability to register or unregister object types. So this means that we're going to be adding the types of objects that we want this specific factory to be able to create. So how do we do that? Well, let me give us a brief sort of walkthrough of the code in words, and then you're free to check it out. But we have this register object member function. It's a static void, so we can call it from wherever. And we're going to figure out our type here, or name our type here. Okay, so this could be plane, this could be boat, this could be plane in the air. I'm going to create one later called ant, because I was just thinking of something new. And the second parameter is this create object callback. And what this is, well, it's a little bit subtle, but at line 17, I've done a type definition. This callback function is going to tell us how do we create whatever this type is. Okay, so we're going to pass that in. Every time we register an object, we're going to give it a name. And then we're going to say, okay, when I want to create this type of object, what function do you call? Okay, and then I'm going to store that in a map. Okay, so I have this s underscore. I like using s as a prefix when I have a static variable. Objects, that's our collection. The type, that's how we refer to things, a plane, a boat, ants, whatever. And then the callback function that's going to create that object. Okay, so then at the bottom of the screen, you can see where my map is as well. And I've used a type def here within this scope to just make it a little bit cleaner, so I don't have to type out string and then whatever the create object callback is, which is just a function that returns a pointer to whatever that object is. Okay, so again, this is the important part. So if we're trying to make it an extensible software and we want some sort of plugin system, for instance, where a user can come in later, modify our code, it's really this register object function that's important. So if you've ever written any software that has a plugin system or whatever, this might be a pattern that they're using. And as far as our factory goes, it's almost the same. So I've got this create single object here, and I just pass in the type here. And when I pass in the type, well, how do I figure out if that's a type that we can construct? Well, I've got an iterator here, and I've got to iterate through all my types and construct it. Okay. So maybe there's better ways to do this. Maybe we can use some random access data structure, to improve on this. But this is okay. And then we'll call the appropriate callback function. So let me show you what that looks like in a moment, which is right here. So how do we create our previous types? So to the right, what I'm looking at here, at line 34 and 35, I have my game object factory : register objects. I'm calling that static function. What I'm going to call it, plain here, and then I have plain : create. Okay, and that's my callback function. So we don't know what this is. We haven't seen this yet, so let me reveal that. And the rest of this code's the same. And I've got a little reader exercise here for folks who want to implement this, but you have it for plain. But here's the new type that I want to add. Okay, so I called it ant, like ants, the insects that walk on the ground, or everywhere in your house or wherever. But this is going to inherit from iGameObject. Same thing as before. What's different, or what I want to draw your attention to, is line 23 through 25. I have a static function here. It returns an iGameObject, a pointer to one. So again, you can choose smart pointer, unique pointer, or in this case, just a raw pointer, and a create function. And if you'll see, this just returns a new ant. So that's where our object creation's being done. And then we can call this static function here, create, for our new type, which is demonstrated here on the right side. Okay, so that's pretty cool. I appreciate this pattern here. Okay, now, one thing I want to think about, and we'll do a little bit of, actually, well, I've got the code here. I'm going to ask this again, but what do folks think about this extensive factory here? Better, worse than just having the free function? I see a couple head nods. Better. Most people are saying better. So if this is something we need, if we need our users or the ability to create new types while the program's running or configure, probably better. We've got a question from online.
Yeah, the question is, why don't we use unordered map for callback map?
So the question is, why don't we use unordered map? We certainly could use it here. That would probably give us O of 1 access, and that would be fine. Yeah. All right. Okay, so we're mostly happy with that pattern. So is the pattern actually used? Because sometimes, we look at some of these things and we say, well, it's cool to think about theoretically or academically or whatever, but is it used? So what I did was I downloaded a bunch of open source programs and I just grepped for factory to see if I could find the class. So one, this is a tip. Name your objects well so that people can find them. But where did I find this? So I just looked in a few projects. So this is a game or graphics engine. It's open source, Horde 3D. It has a factory pattern. And you don't have to look through the listings, but they use it for their plugin system. I see a plugin system down here, and they're creating a node factory. In fact, they have many different factories. Okay, so I see it again in Ogre, which is the object-oriented graphics rendering engine. So it's there. I see it in Blender 3D, another popular program. So it's used all over the place, factory. I saw it in Quake 3 Arena. So pretty much I was getting hits on pretty much every sort of C++ project to see this factory in use, which was pretty cool. And I think that might be a sort of going further exercise from this talk to look at one of these repositories. They're all linked here. They're all open source, so you can see in practice if they're doing anything different. And then, of course, it better be in the game that I'm showing all the time, Command and Conquer here. So it is in the Command and Conquer Remastered edition. Now be careful, because there is a literal factory in the game, but they use the factory path pattern in it as well. So you can see the factory class here. So if you want to actually see for that particular game, it sort of makes sense that they're trying to do something with inheritance. These are the actual game objects and the buildings and that they've charted out. So it makes sense that they're making use of object-oriented behavior. So that's another way to think about maybe design patterns. If you can draw your program out and see, is this a candidate for an inheritance-based data structure? Is there too much, too little? Something to think about. And then I do have a note here. Jason Turner did a source review of the Command and Conquer code, which I thought was really interesting, which may help give some insights here. So again, no design patterns perfect. So just a little recap. We can't hide lots of our implementation details. We only really need to know the type of the thing that we want to create. Sometimes that's a string or maybe an enum class. And these can be relatively extensible, as I've done in the extensible factory. Maybe on the con side, we still need to document how to create types. That's probably useful to our clients. Maybe that's in text documentation or maybe in your actual factory class. You have a little printout that says, okay, these are all the types in my map. That could be a useful thing for your users. And, something to always think about. I don't have any empirical evidence with me, but, if we're using lots of inheritance, would that cause performance issues? Maybe, maybe not. Something we have to think about. We have to test, right? To see if some of these virtual calls can get optimized away, and so on. All right, so a few last notes as we're wrapping up. And this is one I've got to be careful and say, Mike, careful calling it the factory pattern, because this is typically called, what I showed at least in the first part of the talk, the factory method pattern, right? It was just a free function that was standing alone. That said, there are lots of different factory patterns. There's an abstract factory, the extensible factory, which we looked at, distributed factories, many other variations, I'm sure. So those will be the keywords if you want to say, well, this isn't quite what I want, but I know I want to create objects. So just going forward. So quick conclusion, what we've learned about the factory method pattern, a little bit about the pros and cons, and again, thinking about our design pattern. We took it a little bit further by talking about the extensible factory pattern for how we could create maybe a plugin system or make our application a little bit more data or user-driven. We didn't talk about creating multiple factories. There could have been a few ways to do this, right? We could have, this last extensible factory pattern, for instance, I could have made that templated. That could be one way to sort of choose which factory you want. But there are other sort of patterns like the abstract factory pattern, where you have a bunch of interfaces for each of the concrete objects that you want to do, and then sort of another factory sitting on top of that. So those are some other things to think about or what you might want to learn next. All right, so going further, just a few notes, some videos, resources that might be helpful. These were the 3 books that I was skimming while I was writing this talk. There's been I've listed a few CppCon talks here, and honestly, there's been so many that I just put in YouTube, CppCon plus design patterns. And you'll find many, whether related to specific Gang of 4 design patterns, concurrency patterns, or so on. All right, code for the talk is available. All the code should compile, so feel free to play around with it. And thank you for everybody's time and attention. I'll be happy to take questions. A question, yeah.
So one of the problems I could potentially see with this is that it groups everything all together, right? It says, oh, create an object. It is a blank about whatever. Here's your collection of everything. But then I can foresee, oh, I want to make all my planes fly around. So I'm going to go through that collection and say, oh, find if it's a plane, oh, make another collection. It's kind of like, here's all my objects. Oh, wait, they all behave differently, so I have to do something differently. Is there something that can kind of mitigate that? Basically, you've made your beautiful collection of everything. Oh, wait, they're individual things, and I need to do individual things on. Yeah,
so to repeat the question, if I understand it, we've got all of our creation going on, and let's just maybe put one of the code snippets up here. In whether it's the extensible factory or even the factory method pattern, right? It's all in one place, but these objects might behave differently. So one thing to think about is, I guess, if we truly have different behaviors for objects, should they be in the same sort of inheritance hierarchy? We probably want to push them out somewhere else. So this is where we probably have multiple factories. So, a quick way to adjust it, or a quick hack would be to, just make this class templated. And then I have one for the iGame object, one for, buildings, or something that's significantly different and would have a different behavior. Now, there are other patterns where if you just really wanted to have everything in one place, because you have some reason or restriction, or it's a small enough project, we could create objects that have different behaviors. The one that comes to mind in the game programming patterns book is called the type object pattern, where you can sort of construct objects. It's like a builder sort of pattern where you can add sort of functionality as you need, or some behavior. Actually, I'd be even careful with the builder pattern, because usually that's sort of the same, like, you're building a car, but is it a Ford or is it a Tesla? But they're still cars. But the type object pattern is one that maybe is useful. Yeah.
Great, thank you.
Yeah.
I think one potential thing to consider with this pattern is, particularly in this slide, we've implicitly coupled all of these types together.
Yeah.
We've required that they have the same create type method, some method that satisfies that particular API, I guess, but it's implicit. There's no way to see that it's there when you're creating the new object.
Yeah, so the comment was about all these objects have a create function for how we're creating it. They're all, I guess, created in the same way, and we can't parameterize them. Is that a fair saying?
Well, they're coupled in the sense that they have to match, but it's implicit because it's not like an interface where you get the warning that you're not implementing a required method.
Right. Okay, yeah, so the comment is about, we have coupling going on here. Usually we don't, we try to decouple, yeah. Question online, and then in the front.
Are lambda functions an option for object creation? In this example, instead of setting up a condition chain like if or switch, perhaps passing in lambda function to create specific objects.
Pardon, I missed the first part of the question. Was it about inline functions?
Are lambda functions an option for object creation?
Pardon the first part?
Lambda function.
Oh, lambda functions for creation. Yeah, so I would probably model this, right? I could create a stud function here and pass in, something callable. Let me think about lambdas though. As long as I'm returning some object that's been created, I think that's okay. Maybe that's a clean way. Maybe that's another extensible way to sort of create types on the fly or register them. Yeah.
So first, comment on other questions. Since you're returning an iGame object, there's an interface. If you make create, if you're virtual, they have to make create. It's got to be static.
So the comment was about if we're returning iGame object and this is an interface, do we have to implement everything? I think is what we're thinking about, yeah.
And then the question was, have you played around this with this in the expert context instead of like in the beginning of your main doing all that, just register everything during the compile?
The comment was about using const expert to see if it would register everything during compile time. I actually haven't played around with it. That's a great experiment, though, to see if it'll register. Good performance hack. Another online question?
Do you have any guidelines on how this could be applied without using inheritance?
Without using inheritance. For the factory, yeah, I mean, I think, so how would I implement this pattern without using inheritance? I mean, so our other sort of object-oriented tools are, using composition to, this is another, I'm blanking on the name. Let me put the book in front of me here, on the game programming patterns book, that has a few nice patterns where basically you can construct objects, read in some configuration file, and I don't know if this is the heart of the question, but if you're talking about some sort of component system, because that's sort of our other tool, right? Without inheritance, we can use composition to maybe create a different object or something with a different behavior. So that's something to think about. So I believe the time's up for the session. I'll be in the speaker room and happy to talk with anyone who has questions afterward. Thank you again.